Hello, my name is David Mitchell, student number 0003486696, and I'm going to be demonstrating Milestone 2 of Cloak and Scepter, which is my capstone project. I'm going to be demonstrating three aspects of the project. The first is the semantic and episodic memory system, formerly the trust system. This enables characters to form long-term memories about events that occur, as well as remember facts about objects and characters in their environment. Second, I'll be demonstrating the dilemma system and the kingdom narrative. The dilemma system is the core of the gameplay in Cloak and Scepter, and these are issues that you're faced with as a member of the royal court related to your particular office. So for instance, an office of taxation might be presented with tax-related issues that they have to decide how to resolve, and that will feed into the kingdom narrative, which is the story of the kingdom as a whole. Finally, I'll be demonstrating the application in a deployed environment, specifically Microsoft Azure. So first, I'm going to be doing a brief demonstration of the episodic and semantic memory system. I'm going to demonstrate this by speaking to Willie the Wizard here, telling him to remember the name Professor Adams. This will not inherently trigger a memory, but this will be put into his short-term memory, and when the summarizer that creates the long-term episodic memories and semantic memories about facts is called, it should remember these, the statement here. So I'm going to say hi to Willie.
Well met, Aurelian Valens, and a pleasure to make your acquaintance, Professor Adams. This way, if you please. We have an appointment to attend to.
Okay, very good. So as you can see, he read what I wrote there. So I'm going to demonstrate the episodic memory creation. So I'm going to find Willie the Wizard. And we can see here on the right side, this is Inspector. I created a little tool in the Inspector to automatically create an episodic memory. So I'll click this. This is test to pass. It will create an episodic memory. This calls another LLM using something called the Game Master, which is actually a generic LLM that can affect basically anything in the game, because everything in the game is a specific type of object, an agent object, and every agent object has a default and generic type of data called statuses. And so this Game Master can not only create episodic memories, it can also adjudicate combat in the game. It's what creates dilemmas and advances the kingdom narrative. It's basically a tool that can do anything in the game world. In this case, it created some episodic memories. So we can see here that the summary of this memory that it created was I greeted Aurelian Valens, the main character, and Professor Adams, guiding them to an appointment in the throne room. And it didn't create any new semantic facts about objects because there weren't any new facts to create, but it did successfully summarize the short-term memories that were in Willie's memory. So let's test to pass. Test to fail is if I try to create a memory episode and there were no new thoughts or memories to create based off of no new memories in that character's short-term memory, basically. And so when I tried to create the memory episode the second time, it says no episodes were created, and it's because there weren't enough new short-term memories in order to create a new summary of those short-term memories. So this is a demonstration of test to pass and test to fail for the episodic memory creation. So now I can provide an example of the code for this. And so what I'm going to be demonstrating here is the Game Master code. So I'm going to show that now. Okay, so this is an example of the code for the Game Master. So the Game Master is a generic system, as I mentioned, that can change almost anything in the game. All of the data in the game is in the form of statuses that are tied to particular agent objects. And so in order to change anything in the game, whether it's a character's stats, their HP, the model that's the 3D model that they use, sounds that they play, basically everything ties into the status system. And because there's a single unified interface for everything, it allows a LLM to change anything in the game. So this is an example of the system prompt for the Game Master. As it mentions here, you only modify the statuses of objects. And so this provides generic instructions for the Game Master. And then there are specific prompt injections. You can see here the prompt injection right here. And these specific prompt injections include the specific instructions for what the Game Master should be doing at the time. So for memory creation, there's a specific prompt injection saying that it should create new memory episodes after being fed a whole bunch of statuses that represent the short-term memory of the agent. And then it can automatically create these statuses, these episodic memory statuses, and then they're stored on the character and then are read from the character in the process of the prompt generation for that character. So this is an example of the Game Master code. Okay, so next up we'll demonstrate the dilemma system. So the dilemma system is core to the gameplay in Cloak and Scepter, and this system creates problems for you to deal with as a member of the royal court. In this case, you're in the Office of the Frontier, dealing with issues related to border incursions and territorial disputes. So I can create a dilemma, and the Game Master will query the LLM to create a problem based on the current situation in the kingdom and the office. So it created looks like a border incursion issue, appropriately. And then I can decide how to respond to it. I can choose one of these different options here or write my own custom response. And depending on what I decide, it will again call the Game Master, and it will determine how my decision affected things. So I sent a contingent of frontier guards to establish a presence along the border. So the effects that this had is it increased my influence in the court by 5 points. The military commander lost 3 influence, and the emperor lost 300 gold because it cost money to do that. And so you can see here, this value right here is your influence, and my influence increased by 5 as a result of this decision. So that was test to pass. Test to fail would simply be that I cannot issue edicts or make decisions for any other office, although I will be able to see if other offices receive dilemmas. For instance, the emperor has a dilemma here relating to a legitimacy concern for the emperor himself. So in regards to how these dilemmas affect the greater world, there's the kingdom narrative. So the kingdom is called Valenthar, and there's a story here that seeds it, the narrative. And then anytime any characters are presented with dilemmas, these dilemmas are added to the kingdom narrative, and then the decisions are added as well. Then as time goes on, the narrative will automatically advance approximately every week, and then based on the decisions you and other characters have made, it will advance the story of the empire. And then this will then be delivered in terms of news to the king, and so the dilemmas affect the kingdom narrative helps define the dilemmas, and all of these things affect the character's influence and money. So that's the core of the gameplay, and that was test to pass being resolving a dilemma, and test to fail showing that it's impossible to issue edicts or resolve dilemmas for other characters. Okay, so we can show some code here. This is some code for the prompt injection for the dilemma resolution. So this is added on to the Game Master's prompt. So we can see here it will include some additional context that the Game Master might need. For instance, it needs to know about the dilemma itself, the whole kingdom narrative, as well as which agent is responding to the dilemma. And then there's also some instructions here that help define the format of the response and some specifics about what the Game Master should and shouldn't do when creating a resolution for a dilemma. So this is an example of some code for dilemma resolution. Okay, so finally we're going to demonstrate the game running live in Azure. As you can see, I have the game here. I'm going to refresh it, and it's loading directly from Azure. It's cached, so it's loading a little bit more quickly than the first time, which is typically 2 to 4 minutes, but I plan to reduce that. So as the game loads and I start the new game, I'm just going to briefly mention what we looked at. So we looked at the trust system, we looked at the test to pass, creating a memory, test to fail, creating a memory with too few short-term memories. We looked at the code for that. We looked at the dilemma system, both test to pass, creating a dilemma, test to fail, attempting to resolve a dilemma for a different character, along with the code for dilemma prompt injection. And finally, we're observing the deployed environment here, seeing the game working fully on a deployed environment live in Azure. So that's it. My name is David
traveler.
Mitchell.
I am Willie the
Student number
Wizard, your humble guide through the labyrinthine
000348696,
wonders of this
and
kingdom.
thank you for watching.
Don't mind the threadbare